Hello, everybody, and welcome to today's webinar presentation, Batten Down the Hatches, Using Open Source for Smooth and Secure Sailing through Kubernetes, brought to you by Palo Alto. I'd like to introduce you to our presenter, Stephen Jaguar. Stephen has experienced a wide breadth of technologies throughout his career in the aero, telecoms, and automotive industry, improving quality, safety, velocity, and efficiency. Currently, he's a developer advocate with Bridgecrew by Prisma Cloud, specializing in cloud and infrastructure security automation. Prior to this, he was a solution architect for StackRox and Aqua Security, specializing in container and Kubernetes security, and he spent time with Synopsys, establishing DevSecOps best practices for enterprise CI/CD pipelines. And with that, I'll hand it over to Stephen.
Okay, thanks, Lucy. That was amazing. And welcome. Welcome to this webinar, Batten Down the Hatches, featuring my first mate, Checkov. I guess Checkov was an ensign, wasn't he? So let's call it Ensign Checkov. I'm your captain on this journey, Steve Jaguar, and as my intro indicated, I am a developer advocate for Bridgecrew. There's a little bit of contact details there, my Twitter, and I guess a somewhat egocentric URL to a domain. But let's get going. Let's do it. Let's do the required intro bit. A brief more about me. Yay! I've been a coder since 19 redacted, and then moved into something quality automation, if that's a thing. It was then, certainly in 2005. And you can't have security without quality, so it was a very seamless transition over to security, code security, primarily application security back in 2014. And I worked for a bunch of companies in that space, landing mostly into cloud native security, specializing in Kubernetes and containers and all of those wonderful things. I also organize a meetup if you find yourself in London called the DevSecOps London Gathering. I organize that with a few friends and colleagues. And I have a cloud native security Twitch show. So if you want to learn more about that, that is my LinkedIn QR code. If you dare just scan a QR code. I'm very friendly on LinkedIn, and we can chat about all things security. But today we are talking about infrastructure as code. What problem does it solve? Is there more than one type? Does it rock? Why does it rock? What is GitOps? Okay, you probably know what GitOps is, but I'm going to try and put it into a creative context involving how it works hand in hand with infrastructure as code. And then I'm going to get into the rough definition of the code journey, because that brings context to the different hatches that I'm going to be progressing through, or actually progressing backwards through. So we're going to go keyboard to Kubernetes, then I'm going to start applying security, starting at Kubernetes and moving backwards to my IDE. So we can see how it actually kind of gets easier and more to our benefit as developers who are writing manifests and deploying things on Kubernetes, the further we shift all of that left. Doesn't have to be totally left, but we'll learn some lessons on the way. It makes things easy, and we'll learn how to use Checkov, which is, well, we'll talk about that shortly. It's an open source infrastructure as code misconfiguration scanning tool that is free, which is nice. Okay, let's try and do a little bit of background. We are looking at the OWASP top 10. If you are unaware of that, OWASP is the Open Web Application Security Project. It's another free community-based thing, and they have a top 10. Consider it like a leaderboard. What are the worst? What are the things we're doing the most wrong at the moment? When it first started, it was very application security centric. And why? Because we were creating great big complicated applications, and we were putting them onto servers in data centers, and they were outwardly facing. They were facing the internet. And most of the things we were doing wrong were to do with the application we were writing. The larger the applications got, the more spaghetti code got in there, and the more there was just no way to understand all the logical paths through our application, and therefore lots of interesting things were on here. In particular, you can see number 3 there is injection. Injection is the abuse of unsecured input data, say into a form. You convert that into an SQL query, and suddenly you can actually start executing on the database. We're pretty good about those things now, but it was at number 1 for almost 10 years, I believe. And yet, we still kept not fixing it, crazily enough. And there's another one down there, server-side request forgery. Again, these are very application specific. But what magical thing changed about the OWASP top 10 in 2021, this is that list, is there was a new number one, for one, broken access control. They became very cloud native centric. Insecure design in at number 4. Interesting. Security misconfiguration. What we're going to be talking about today is at number 5 of the thing we do wrong the most. Now, broken access control is also in there and also part of infrastructure as code security, so we're taking note of that. Certainly, vulnerable and outdated components are all part of our supply chain, and you can see a lot of the stuff there. It's all oddly gone cloud native, and what a surprise. In 2017, the world was a different place. Putting Kubernetes into production, well, you were daring, let's just say that. And now it's a no-brainer. We're thinking in a few years it'll become ubiquitous. We won't even talk about it. Abstractions will be there in place of Kubernetes now. So it's interesting to see how this has changed. Essentially, those coding issues, that application security, those vulnerabilities have been replaced by misconfigurations and dependency-related issues. What if we get it wrong? What happens when we get these things wrong? Well, I'm just going to say misconfigurations. What happens if we configure anything wrong? Well, the easy thing is the lucky thing is that we get unintended behavior, right? Doesn't quite do what we expected. Okay, that's minimal. A total outage, that actually is probably more common than some of the other things on there. For example, the idea that you're combining infrastructure as code with console ClickOps, and you get a disconnect between what your runtime looks like and what you think it's actually doing, and suddenly you do something wrong. Or malicious, a data breach. If you've got something as simple as an S3 bucket exposed, I know this is an old school one, but for some reason it's still in the news, and the data can just be directly read from somebody anonymous on the internet. A little bit more elaborate are things like lateral movement. So you provide what seems like an innocuous way into your environment, but then they're allowing them to crack through the hard shell of the egg into the soft interior and move around inside your environment. And from there, we can get things like supply chain compromises and personally identifiable information being exposed. Security best practices are more important than ever. Now, I've got a screenshot over there of a vulnerability. If you're unfamiliar with CVEs, common vulnerability enumeration, any public vulnerability gets one of these numbers. They used to be very much associated with application vulnerabilities, but now, and this is one of the first ones I saw last November, this was almost a design issue / configuration issue in the Nginx ingress that is used in Kubernetes, and you could abuse it to extract information from a Kubernetes cluster. To be precise, every secret concealed in that cluster and thus take over the cluster. Very, very bad. All of the things in that list could happen because of this. So it was really bad, but it got a CVE, and early Kubernetes flaws they just bypassed the whole CVE. They weren't considered a first-class vulnerability citizen like modern misconfigurations are. So that's all good things. All right, switching into the other element of this to provide further context. What is infrastructure as code? And I'm sure you have a definition in your head of what it is. If I were live, I would ask for questions, but you can see that I've marked some of these. I've got some in straight up bold. I've got some in straight up italics. And then I've got one in the middle, which is in bold italics, which is polemy. The way I'm separating these out is declarative infrastructure as code versus procedural or imperative is kind of the opposite of declarative. What that means is the way they're written, and I think the familiarity lies more with imperative because we've all written a script in some language or another. You know, it could be I think in the summary for this talk, I mentioned the autoexec bat file on a PC back way back that would just run some initializations and things when you first start up your PC. We've all written shell scripts probably. These are imperative. These are repeatable things that I want to do again and again. Ansible is a more advanced version of that. Pulumi is this halfway thing. Now, I'll talk about that in a moment, but what I want to focus on today is mostly declarative. The major language as well, we're talking about Kubernetes. YAML is declarative. YAML manifests for Kubernetes are saying, this is what I want. Now, what you could be using an abstraction like Helm, still doing the same thing, saying, I want this, just doing it in a more scalable way. Kustomize is a little bit like Helm, but it's allowing me to send the same thing into different environments with subtle changes. So they're all the same thing. Same with CloudFormation, Serverless Framework, ARM, Terraform. These are all just saying this is what I want. And yet Pulumi is a hybrid. Pulumi is using common languages that we already understand, like TypeScript. So they look Turing complete, like I can create loops and do all this, but it renders it as a declarative format before it deploys. And there are good and bad elements to that, but it's kind of in the middle. Now, I'd like to just kind of define the difference between these two using cake. And if you've seen any other of my talks, I seem to somehow work cake into most of my talks. That looks delicious, by the way. The procedural version of cake is a recipe. And if you've ever made a cake, you know what I'm talking about. It doesn't look like this because you've never made a cake with bash before. I'm sure most people haven't. You would run the obvious bash commands: preheat oven. You'd set your layers to 0. Oven temp, check the oven temperature, and then you go into a loop creating your layers for the cake. You run mix flour, you run bake, and then you got your layers, and then you can see what's going on here. If I want to create a Kubernetes cake, I create a CRD, let's say in this case, of type cake. And then I start to say I want 2 layers. I'm going to have chocolate icing. I'm going to use the fluffy sponge container because I can trust that container. It comes from something that I feel I can rely on. And then away I go. Now, the difference really, I think, critical for me is between procedural and imperative and declarative is that, well, say I remove the cake. What am I looking at here? Like, do I know what this is making? With these procedural commands, I now need to really understand what these commands are and what they do, because if I don't know it's making a cake, what's it making? I look at declarative and I know what it means. The other important thing, the difference between these two, is this kind of strange word called idempotency. Idempotency means if I run this and it already exists, does it change the outcome? And because declarative is asking for a state, if there's already a cake, then it goes, oh, I've already got a cake. Great, no need to make a cake. Whereas if I run that bash script, I'm going to get 2 cakes if I run it twice, 3 cakes if I run it 3 times. So that's another nice thing about declarative. Okay, and actually that is involved in security as well. So that's the differences. And then I'm going to tie that into GitOps. Now, GitOps was coined in 2017. It was coined by, there he is right there, Alexis Richardson. And he was first describing GitOps patterns shortly after Kelsey Hightower, who's kind of a big celebrity name drop clunk in the Kubernetes and cloud native space, said GitOps is the best thing since configuration as code. All right. But for me, it was important that he also said declarative configuration is the key to dealing with infrastructure as code. And I totally agree. He alludes to something that I'm going to double down on, the setting the stage for the next generation of tools. Now, I'm not just going to say management tools, I'm going to say security tools, and I'm going to be using one today. So the idea is, on a postcard, code as the single source of truth, runtime immutability. And that means we don't change runtime, we change code. We don't tinker with the runtime because that's, once it's there, it's there. Ugh, I don't want to mess with that because then you get that out of sync thing and we can lead to some bad things. So we're going to keep that in mind. We're going to move swiftly onward with a quick recap, and then we're going to talk about the code journey. So important things I'd like you to take away: declarative infrastructure as code indicates required state. It is saying what I want as opposed to how I get it. Great. Our declarative infrastructure as code today will be written in Kustomize, which is a tweak on YAML for Kubernetes. Kubernetes open source infrastructure as code languages are all declarative, and they are declaring resource objects and their relationships. There's always connections between them, and that's also important to know. GitOps establishes Git as the single source of truth. Git equals runtime. Implementing security at this stage is not only smart, but it is just much easier. And hopefully we'll see some demonstrations of that. Okie dokie, moving swiftly onward. the infrastructure or application code journey. What's great about GitOps is that when I first heard about GitOps, this is a little anecdote, I thought, what's the big deal here? I've been writing application code and putting into source code control my whole career. Now, because it's in infrastructure, it's like a big deal. Oh, okay. But now it wasn't until we started implementing high-speed CI/CD platforms and the idea that everything was traceable and attribution was always possible, and it was within a developer workflow that I realized, you know what, this makes complete sense to do everything as code, but I digress. The code starts on our desktop way over there on the left, and it moves through maybe we do some things in CLI. If we're running pre-commit, if you don't know what I mean by pre-commit, that's okay. I'm going to show you what that means. And then it runs and goes to CI, and this can be GitHub Actions, it could be Jenkins, it could be GitLab, it could be Circle CI. Many versions of that are available. Once it's all good to go and everything's assembled and all the parts we need to deploy are created, it goes into our continuous deployment example. I have an example later, which is Argo CD, and I'll have just a screenshot of that. And then it's in runtime. Now you see where I've got the different color codes, blue, blue, blue. And then I have got my CI. And then we're getting a little slightly more red. Now that's just meant to indicate the difficulty of applying security. If we're here at runtime, it's difficult to apply security. We are monitoring, we are guessing, maybe we're using ML and AI to figure out what does an anomaly look like. It can be really hard, and it is. And what's worse is that there's some well-researched ratios of the employees, so thousands of developers on this side, links to hundreds of ops to 10 security people. So we have the minimum amount of people and the most complicated things out there. And in fact, a resource that can exist as infrastructure as code can be deployed in the opposite numbers. 10 of these can become 1,000 of these, which just scales out our security problem immensely. And you see I've got a little arrow over CI. That's because if you're looking at how to deploy security, CI is kind of your return on investment. It has visibility for security, so they can see that they are shifting part of what they're doing into automation, and they can see they're pushing it a little bit left. And plus, it's the center of automation. And so it's the easiest place where you have the most people and the right ratios between either side to put security in place. So if you haven't got security for infrastructure as code in place yet, expect that's where it's going to show up first. And we'll talk about how to do that in a moment. And we're going to do it using Checkov. Why? Because I work on Checkov. It's the tool I commit the most to. It's a great free and open source misconfiguration scanner for infrastructure as code, intended to be used in CI/CD pipelines. Hey, voila. Thousands of built-in checks across many infrastructure as code languages, including the ones we'll be using today. It has very simple best practice checks to complicated graph-based checks, which look at relationships between infrastructure as code objects. Not too bad. The victim of my Checkov today will be a Kustomize simple Nginx deployment. And if you want to learn more about Kustomize, that's actually the link to the repo for what I'm going to be using in the demonstration, should you want to know. Kustomize is a very simple way of overriding a base set of manifests with specifics tailored to, say, my dev versus my prod, those subtle changes you might want to do. It's very clever. If you don't know it, I suggest looking into it. All right, enough me talking. Let's look at things. And a little bit of a caveat before we get going here. I did record out of paranoia some of these demos beforehand. So if it doesn't look like I'm actually typing, it's because I did it a little bit earlier because I was scared it wouldn't work. So it's like pseudo live, let's call it that. All right, hatch 5, just a little bit of context actually before we go back. If you're into the hatches, hatch 5 is CD and we're working backwards. We're not gonna look at runtime, we're gonna go from DI to pre-commit to CLI to desktop. Those are the 5 hatches. I probably should put it on a slide. What are we doing at hatch 5 in CD? Well, what we're securing us here is a Kubernetes admission controller. The way if you're familiar with how admission controllers work, great. You're probably ahead of a lot of people if you know how that works. If you're wondering what's going on with those, A developer, or symbolized here by a CD platform, is going to apply a particular manifest to Kubernetes. Amazing. The API will first authorize whether you're even allowed to do that. Then it will send the object to the validating admission controller. We call ours Wharf because I don't know if you noticed, but there's a heavy Star Trek theme going on here. And it will send it in. It will utilize Checkov to say yes or no based on a set of rules that you can define as to whether we're going to let that be persisted in etcd and become a running Kubernetes application. If not, it gets bounced back. All right, we've set that scene. What is good about an admission controller? Well, we have the one that we've written. There's a lot of, remember I said 1,000 rules, right? We've distilled that down to just a few essential no-brainer rules that are just the really bad ones that you just shouldn't have in place. The security, those settings can be committed to Git, so you're still doing security GitOps. Very good. It's running Checkov under the hood. Now, there are other admission controllers. There is a great one called Open Gatekeeper that uses some amazing rules written in Rego. Okay, use that. The important thing I'm trying to stress, though, is that you're using a consistent definition of security policy as code throughout your entire pipeline. You'll notice I'll use Checkov in every single demonstration. Great. If you're not using Checkov, make sure you're using the same thing at every hatch. That is my advice. But Chekhov's great, so use that. I'm biased. You can also get detailed visibility through the Bridgecrew platform. This is a bit of a shameless plug, I know. But when Checkov runs, there's a generated free API key that just sends kind of like, it's really hard to do history in Kubernetes. And you can create a whole bunch of complicated CRDs, but we just send it to our platform. You can go look at the details there, and that is a free feature, so you can do that. The cons of an admission controller. All right, and this probably goes for all of them. The errors are not that convenient to developers. They really are not. The people who often wrote the manifest will never see what these errors look like. Fixes just for any policy as code solution often require reading documentation. I actually will show you what that looks like later on. So let's take a look at what it looks like to be blocked by an admission controller, shall we? All right, let me move this out of the way and get going. All right, here we go. So first we're gonna see what pods I've got running in this cluster. It's almost completely empty with the exception of the Bridgecrew admission controller. You can see there the validation webhook. Okay, great. Let's take a look at our application. You can see I've just done around a tree. And ignore the stuff at the top. There's Kustomize there. There's my base. You can see my deployment, my service, and my storage. That'll be used across all different parts of the cluster. So whether it's dev or prod or test. And what I use here is these different overrides or overlays, like a class mechanism in any language. It just overrides part of what's in the base. I can add more security. I can take it away. I can do whatever I want. So that's the idea behind this. And the way I can try and deploy this is I can Kustomize is built into kubectl, by the way. So I say -K, it's the same as -F, and I can point it at the overlay. And kubectl does all the clever stuff to normalize the base with the additions, and then we'll try to deploy it. And you can see it's went backwards and grabbed the service, it's doing the storage, it's doing all the things I need, except that it's gonna get sent to my admission controller because I've already put that in place. And boom, it got rejected. All right, why did it get rejected? Why has it not been persisted in etcd? Well, this first line, if you've ever seen any admission controller, it's generic from Kubernetes. The stuff that we're sending back is this. There was 2 issues that were in violation of the admission policy, and that's this one. Allow privilege escalation was present, and it was admitting a container that was root. Well, that's bad. I am noting that there's a lot more issues in this than we're showing you. We're just showing you the really bad things. And if you want to go look at the rest, remember I was saying you can go look at it in Bridgecrew, then you can go see the entire thing, and that's just a convenience that's there for us. Now, a CD system wouldn't be doing this manually, right? You'd be using something like Argo, and this is what I mentioned, and you would be running a GitOps synchronization method, or you'd use Flux or something like that, and it would try and synchronize the change in Git with my cluster. And if you had the admission controller in place, it would just not sync, and you get something like this. This is the Argo version of it, where it says, hey, failed sync attempt. Now, what's annoying about this is if you thought that was hard to read, try and read this thing. Like it's even killed off all the new lines. So it's like, check, it's all one gigantic sentence. And you're like, what? These aren't clickable links. It's just a little bit rough around the edges, from a developer experience perspective. All right, so we've seen what can happen. The good thing is, another good thing about admission controllers is that security teams kind of like them because they generally have control to put that in place independent of developers who want to put applications into Kubernetes. They can get something, they like this and they put it there, and suddenly you're like, hey, why am I getting blocked here? That's weird. So it's a little bit security centric, let's say. All right, so let's go to CI, and I'm going to be using GitHub as my example because it's free and easy to use. Why not, right? The pros of implementing a security control in GitHub is that I can be more than the no-brainer checks. I can do really advanced checks. I can also keep them in Git, and plugins are almost always available out of the box for everything. So whether you're talking Circle CI orbs or GitHub Actions from the marketplace, Checkov is there. You can just go get it, drop it into your workflow, and pow, you're doing instant security. Super easy, takes no time, almost takes no training, and off you are running with some security. Of course, the cons again, how many developers are looking at that? I work for a very small part of the organization, so I get to see when I screw something up in my GitHub Actions, but not everybody does. Let's take a look at how this looks. And it'll be better than the admission controller, but it's not perfect, All right, so here's customized code. This is the repo we were just looking at on the command line. You can see, yeah, that's definitely it. And I'm going to click through into workflows, and we're going to see I've got two workflows, one for dev and one for prod, because I had two different sides to my customize, right? Not too bad. We'll click at dev. We'll take a quick look, and we can see, all right, so it's gonna fire the security check if anybody changes either dev or base. All right, fair enough. And all it's doing is a security check. That's it. And I've dragged test with Checkov in, got out of the marketplace, made a few little changes to tell it that, oh, by the way, this is a customized framework, so you should know. And so I didn't waste all of our time. I already ran it. There you go. And we're going to check out the result. Now it's build looks like it's failed. Well, the build is just a test. And we are taking advantage of annotations. So we can see, oh, okay, so this is interesting. I can see some of these things here. All right, good. You can actually click these and go straight through, and you get the more detailed output in the GitHub and the logs. You can see test with Checkov. We can scroll down. We can see the nice little logo there. And it's cool. I can even see the things I did right. I can see what I passed. That's nice. Maybe too much information, actually. And then we can see the details and the things that I made a mistake. So here, ensure that service account tokens are only mounted when necessary. Do I need the service account token mounted here? I do not. That can be dangerous. Remember that thing I saw earlier about Nginx ingress? Getting the service account can give you the keys to the cluster. So I just clicked on the app. There's a cut and paste code segment. Okay, ace. We'll come back to that a little later though. That looks easy enough. So let us move on to hatch number 3. Now remember, this doing stuff in CI is like super easy, and certainly when you do it regularly, you don't get a big list of stuff. You get a much smaller list, and it's certainly easier to manage. But this was an example of building a bunch of stuff and then checking, as opposed to being incremental as we go. We will learn how to do that shortly. Pre-commit. Now I'll explain what pre-commit is in a moment, of course. The pros of using pre-commit hooks when you're using Git. Again, same as before, far more granular security controls. Controlled by Git, errors are for the first time conveniently visible to developers. Good, I like that. You don't have to use the Bridgecrew platform, by the way. I should thought I'd throw that in there. It's not like it's required. The thing's free. You can use Checkov without anything if you want. The cons. You thought you were done. I use pre-commit hooks intentionally, and I have forked and cloned a Git repo once, and I've got pre-commit installed on my MacBook, and I tried to make a change, and it ran a linter and told me I wasn't allowed to commit, and I was thinking, okay, right. if you waited a long time before you let it check, there can be a lot of errors, which are difficult to traverse. So let's see what a pre-commit looks like and maybe learn a little bit more about what it is as well. Here we go. All right, maybe that's out of the way. All right, we're in the same place as we were before. We can see there's the tree, same stuff as before. Fantastic. I'm going to do a get status. So we can see that I made a modification to deployment, whatever that mod is. There's the pre-commit config I've added. Amazing. We can go over here and we can see, all right, all I did was add a little label. It says stage, base. And this is, if you're wondering what it is, precommit.com. You can go here. You can learn how to install it. I used a brew install pre-commit. Very, very easy. Cut and paste this example configuration file. You commit it in with your repo. We can see what mine looks like here. I'm using Checkov, of course. I'm pinning it to a version. I'm telling it it's a customized framework again, and I'm giving it a directory to go scan. That's how easy that is to put in place. And you can see based on my status, I have some things ready to go. So I'm just going to commit those and say, all right, I added my labels, and I need to do a little upgrade, and it's running Checkov as I have in my pre-commit. I can presto, whoa, here we go. There's all, now this is much nicer looking than it was in the Git logs, wasn't it? Because I can see the file, I can see the section of the file, like the object within the file. I've still got all my help links. I can see how many there are. Remember we saw 17 things were wrong? They're all here now because I didn't filter anything out. It's just all, it's all there in all its glory. I can work with that, but it wasn't that friendly, was it? 17 things. Maybe I know what's wrong, maybe I don't, maybe I understand them. Is there a better way? There is a better way. Let's go to hatch 2. Now this is debatably a better way. I think it's a better way, and I'll show you why. No, they're both good. Do defense in depth. Far more granular security controls, errors are invisible, same as before, right? Why would there be anything different? It's running the command line. There is a con that pre-commit is part of automation. It can be checked into a Git repo by security who want to make sure you do this bare minimum. There can even be a config file that automatically bypasses certain of our policies or checks with Checkov so that they're tailored to that repo. So there can be overrides or suppressions that can be built in there. So they can do security, and that can be under the control of SecOps essentially. And that's great. But if you're just going to run the command line, that's not part of any process. That's down to you actually to run that. But huge advantages. You can run and you can find things even earlier than commit. That is a positive. Once again, there can be lots of errors. And to run the command line, you actually need to understand the command line options. How hard is that? Well, let's take a look, shall we? Checkov is both super easy and super complicated, like all command lines. Like, not like AWS complicated, but let's run Checkov and do the help. Now, if you spied that I've got a little helper app on my desktop, that's a little helper app called fig.io that does that for me. So if you like that those kind of hints, you can go check that out. So look at all the options. Checkov has features. There's no doubt about that. Do I want to learn all those features? No, not really, right? I mean, I know because I wrote some of them, but let's try and do it the easy way. Even I use this helper. Framework, look, I can see all the different frameworks I can use there. I'm saying it's Kustomize. Now I'm going to say, just check everything below where I am right now. And I'm going to give it a path. I'm going to do dev. Again, same weakly configured Nginx. Now, things I do know about the command line is that I can add different parameters, in this case, that I know to make my output as quiet and compact as possible. So what that essentially means is it's not going to show me the things I did right anymore. And it's also going to cut out code segments. So it's really, really tight. You can see we've got all the different things that we had before. Apply a security context. You should do that. And we could see a summary at the top very easily that can easily fly off the top of the screen for some if you have too many things. So that is a nice, certainly more compact result. So I like that. And you can run it wherever you want. And that I would say is how a lot of people use Checkov. They just, as they're writing the manifest, they just go to the command line and type it. And yet, we can shift it even further left, and we can have an even better experience with writing secure infrastructure as code for Kubernetes. By the way, I'm saying Kubernetes because that's my example. You could do it for Terraform, CloudFormation. We started with Terraform, so our Terraform coverage is phenomenal. Patch 1. IDE security on the fly. And this is what I use, and this is what I recommend everybody use because it ticks all the positives. You get all the same stuff you had before, controlled in Git, errors, and I'm going to talk about this, errors and in brackets and fixes with a little star, conveniently visible to developers. No need to learn the command line options. Hurrah. When you're done, because if the IDE says you're good, even if you have pre-commit in place, it's not going to block you. Hey, even if you have it in CI, not going to block you. Even if you have it in CD, not going to block you. All right, this is all sounding good so far. What's the catch? I don't know, you got to click the thing in VS Code and install it? That's a whole 10 seconds. Let's take a look. All right, here we go. I am in VS Code. This is also available for JetBrains, anything by JetBrains, so worth knowing that as well. So say I'm looking at my deployment. Here it is. How simple is that, right? That is a cut and paste from the Kubernetes documentation with some slight changes. You see the little squiggly line? Hey, there's all that same stuff we saw in the command line. Set comp, memory requests, scroll down a little bit. Security, oh, there's that one there. Ensure secure service account tokens are only mounted where necessary. That appears to be 4 from the bottom. You see it says no quick fixes available. I'll get into why it says that. But okay, all right, that's good. I can click on the docs, and there we are. It's like this is the docs from before. Still there, still up. And remember, before we saw that cut and paste. I'm like, well, that's easy. I could read this doc, but I get it. There's a cut and paste there. Only thing I really need to notice is that was a pod. This is a deployment, so I put it under the pod spec, not the deployment spec. It won't do anything. That'd be the wrong spot. So there we go. You can see the change for Git is marked in green, and I added it, and Checkov immediately starts to scan this again and say, all right, I still have some problems. You notice I rolled down to the bottom, the one was the 4th one down, and it's gone. Okay, so that was easy. I just clicked the blue link, I cut and pasted, and I'm secure. Now, granted, if I keep doing that, look at this one. This is the one that's secure. It's a little bigger, but it's not that hard to get there. And in fact, I have another talk called Securing Nginx, where I go from the one to the other, and I create the other one by just clicking on the blue links. But I go through and I explain why those security measures are important. Like seccomp, for example, I get into what it means. That's for another time. The summary I'd like you to digest and take away is that misconfigurations are first-class problems. They really are. They are now the thing, arguably more common than your hacker-style application vulnerabilities. One misconfiguration can allow an attacker into the soft, cuddly interior of your development pipeline, and we do not want that. Infrastructure as code equals GitOps. Yes, they're one and the same. One cannot exist without the other. Defaults, even from trusted sources, are not secure. I did very quickly say when I said, hey, look at this Nginx. If you go searching for Nginx deployment on your favorite search tool, let's say DuckDuckGo, probably more likely Google, one of the first things that will come up is the kubernetes.io, here's a deployment of Nginx. That was it. And there is a lot not secure about that. It's not trying to teach you security, though. That's the important thing to know. When we learn things, often security is not part of what our learning involves. All right. Infrastructure as code security can and should be applied at all phases. Now, I showed you 5 different opportunities for security. Really, you should have them all, because if you did it right in the IDE, the others will just be invisible. They're just there to catch the odd thing, that trust but verify, that sort of scenario. Defense in depth. Every security person will say defense in depth is good. Infrastructure as code security can be simple. And that was that's the entire thing I was trying to show today. security can be done to you, or you can do security. One of the things, and doing security yourself, it's really not that hard when someone just says, do this. You can look up, Checkov can be found by going to the plugin section of either JetBrains or VS Code and just type Checkov. And lo and behold, there's a plugin. Click it, install it. It'll even guide you through getting an API key for special features. And there we go. That is the last point. Fixing it is much easier done by you rather than in your CI, which is probably inevitable if it's not already happening, or worse, after a, we don't want that, do we? All right. That is the end of my presentation. I think I kind of almost got it on time. I think I was asked to do 40 minutes and I did it. Thank you for playing. There are some links there where you can learn more. Checkov.io, Bridgecrew, there's the repo I used. And if you have any questions for me, I have, my ego URL there, steveshigear.com. That's all. Lucy, I think it's back to you.
Yeah, so we have some questions coming in, and if anybody has any questions they'd still like to ask, please drop them into the questions panel. So the first one that we have is, for Checkov, can I create my own custom policies or extend it somehow?
Good question. Yes, you can. Checkov is totally open source. So I don't have the GitHub for it there, but in Checkov.io connects you directly to GitHub. And all of our policies are written, some are written in Python, and there's a template in some cases just to cut and paste one you see. And the object is passed in as like a JSON object, and you could say, oh, does this and this look correct? And you can create your own policies. We have loads of people who contribute to our community. We have a Slack channel where we all talk about creating new policies. So there's a pretty cool community behind it. Additionally, you can use YAML to create those relationship policies. And we actually have a wizard inside the Bridgecrew platform that allows you to create things that say, does this S3 bucket also have logging in this style? So you can check to see if different resources are connected using YAML style policies. So there's actually two flavors of customization. So yes, it's a great big yes.
All right, we just had another one come in. You briefly showed quick fixes in the IDE, but it was grayed out. Does that auto fix my manifest?
Okay, let me back up for a second then. I did do that, didn't I? It was in, yes, it was in here. So when I was going through here, and this is, of course, I recorded it, and it comes down and says, not auto fixed. Yes, so I said I was going to mention that, and I did not. So some of the languages, certainly Terraform at the moment, has what we would call quick fixes here. And we're working with a team to do this for Kubernetes. So I wanted to mention it. So an example where privileged true can be just flicked over to false, where there's just simple key value pairs that we can say quick fix and just pop and fix the manifests. That's something that's coming soon. We do already have it for other languages like Terraform and CloudFormation, where we're just going to fix those instantly for you. And then there's another advance upon that, which is called smart fixes, where if it's in a very, very big repo and the platform side, the Bridgecrew side, can see the whole repo, we will actually recommend fixes that are based on your own development team's behaviors, which is very cool. New feature, only just came out recently. So that is a thing that's coming. It's not, unfortunately, in YAML yet, though. That's why I put an asterisk on that one.
All right, and it looks like we have one more question. You mentioned and we saw links to the platform. What else does that offer, other than another way to see my results from Checkov?
Oh, okay. I kind of answered that actually a little bit. The whole thing with smart fixes, the platform, some of the things that I did here manually using Checkov, the platform will do. So if I took that customized Goat URL and I said, well, connect this to the platform. And by the way, this connects to something else, say in runtime, it can reconcile that in a certain sense. So if I attach customized Goat to the platform, it will automatically always be scanning it with Checkov. And if it finds that there are problems, sometimes fixes can automatically create pull requests to say, make sure this is fixed. It does create just a far more elaborate and scalable experience built directly into your CI. So it's quite clever for that. In some of the other languages like Terraform, if I'm checking Terraform, then you can actually say, well, this Terraform is deployed into this AWS. And it will tell you, you know, I said it's good that they're the same because you're doing GitOps. It will tell you that there's drift. So if somebody tinkers with, let's say, encryption on an S3 bucket, in the unlikely event somebody would turn that off, the platform will say, whoa, 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 this doesn't match this. I don't necessarily know what's right, but this doesn't match, and it will alert you. And you have two options. You can either fix it in runtime, or it'll create a pull request that will change your Git repo. So it's doing some GitOps for you. Now, that's just like scratching the surface of what it can do in terms of monitoring the trend of vulnerabilities over time. It will create a map of your entire repo and show you your supply chain from runtime all the way back to Git. It does all sorts of very cool things. So I can't get into it now, but thanks for asking. Those are some of the more Checkov related things I'd try to touch on.
All right, it looks like that was the last of our questions.
Cool.
All right, well, with that, DZone would like to thank Stephen for a fantastic presentation. And DZone would also like to thank Palo Alto for providing the audience with a great webinar. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.